Oh my goodness, this is a really good question right here. So, can you do a video explaining prompt and delayed neutrons? Your reactor physics lecture here does not address that. Man, that is a great question. So it's really important to understand in reactor physics the difference between delayed and prompt neutrons. The delayed neutrons are simply neutrons that come about through radioactive decay. The prompt neutrons are those that are released right as fission occurs. So if a neutron comes into a uranium-235 nucleus and it fissions, it'll give off 2 or 3 neutrons right then. Those are prompt neutrons. Now, some of those fission products that'll come off, their primary decay mode, or one of their decay modes, is going to be releasing a neutron. Now, all of the neutrons that are released in this process can then go on to create subsequent fissions. And so when you look at the economy of neutrons, where they're being born and how they're ending, whether it's in fission or absorption, you've got to take into consideration those neutrons that are delayed, the neutrons that come from radioactive decay. Now, those neutrons will contribute to subsequent fissions. And so when you look at one generation to the next generation, so I get a bunch of neutrons, and all the neutrons that came from that fission and subsequent radioactive decays of those fission products, all of those neutrons need to be accounted for when you go to the next generation and creating the next set of fissions to have a chain reaction. Now, because those delayed neutrons are through radioactive decay, it takes a lot longer for those to contribute. And so when you account for those, that amount of reactivity for the delayed neutrons is what we call a dollar. It's just a metric to say how much are these neutrons worth. And when you're doing reactor control, you're never allowed to change the reactivity of the reactor by more than, say, 10 cents or a quarter or something like that, a small fraction of a dollar. That way, you're never getting into prompt criticality. Prompt criticality is where you no longer need the delayed neutrons to sustain a chain reaction. The only way that you can legally operate a nuclear reactor for commercial applications in the United States is that it's always in delayed criticality, so that you always have to have those delayed neutrons to have a sustained chain reaction, and therefore it's always going to have a slow reaction because the radioactive decay takes some time. If you're in a system of prompt reactivity, then the system is going to disassemble itself. That's what always happens. You'll get a thermal pulse that will cause it to expand, and it will disassemble itself. Basically, disassembly in a critical system, and this has happened at the national labs on a number of occasions where you have a prompt excursion and it just disassembles itself. So great question. I hope that answered it. The difference between delayed and prompt neutrons in reactor physics. So thanks for watching. Hope you all have a wonderful day.